Well, hi, thanks so much for joining me here in my shop. Today is the 5th of July. Um, so there's a few capacitors left in here that were in the radio when I got it. There's a lot of these black guys here, and there's this big white one and a green one, and then finally a paper one down here. So I've been looking these over. I think, considering the radio appears to be operating fairly well, obviously I'm going to change out this one because the tone control is doing nothing, and this will be the guy who's responsible for that. This one looks really great. I'm not inclined to do anything with this capacitor. It's pretty new. Obviously somebody else put it in. Likewise with this one and these other new ones that somebody else put in. This one here. So this is a large capacitor, 0.1. It's physically large, but it's also a large value, 0.1. And what is it doing? It's here on the screen grid line here. So this line is shared by the screen grids on other tubes. So what's going on this line is really going on all the screen grids where they exist. So the objective here is to silence any RF or any audio, should there be some, out of this line, so it reaches the screen grids on the tubes is nice, flat, DC. I guess that's the way to put it. So to do that, they put big whopper here. That's a 10 microfarad capacitor. It's part of the 3 capacitor package. That's down here. The other two, half moon, square, triangle. The problem with the electrolytic capacitor, maybe this vintage in particular, I don't really know. I think it's true of electrolytics in general. They don't work so well at high frequency. So in order to snuff out any remaining high frequency signals, there's another capacitor added of a significant size, this 0.1. So the two of them are doing the same thing. Together, they cover everything. Let's put it that way. I guess that's a way to put it. So there is some kind of sounds like a bit of an oscillation in this radio when you're tuning between stations. You kind of hear a bit of a tone of some sort. Don't have any idea what that really is, but could it be because this guy's not doing his job anymore? Not very likely in my book. Now, 0.1, I don't have a lot of large capacitors here. They're a little expensive to stock. So, but I do have some 0.1s that look like this. This is a special capacitor you would put across a power cord or something like that. It's designed to never catch fire, basically. I guess that's the idea of this. So what I'm thinking I can do is I can turn on the radio, we can hear the sound I'm concerned about. It's very subtle. And I could bridge this briefly in here. Anywhere. I can go anywhere to ground really with it. And is that going to have an effect? I doubt it so much. But I could do that. And is the tone I'm hearing, if it's even real, is it because of this? Who knows? Who knows at this point? So I could do something like that. Okay, that's possible. And are there any others? There's an orange drop here, and those are fine. We'll leave them all. These black guys here, my experience with them has been good. I have a couple I've taken out of the radio. Here's how we'll proceed. We'll change this capacitor out. We'll then test all the capacitors I've removed from this radio. I have them all over yonder. We'll test them on the capacitor tester, see if I was doing anything useful. Among those capacitors are 2 of these guys, 2 like this, that I removed from down here, replaced. That sounds like a good plan to me. Based on the results from those 2, I'll make a decision about the rest of them. Chances are they're staying in there though. That's a good plan. Let me get rid of this guy first. I'll show you on the schematic where he is found. Okay, so you have the volume control here and the tone control here. The capacitor we're talking about, let's see if it's this one. See, it's right across the slider and one side with the resistor coming from the back side of the volume control, basically. backside resistor. What's this one? Yeah, that's right. So if you connect this one to ground, you could find the ground on the end of the slider, which is what they've done. So this is actually wired in from here. Well, it's really wired from this point to the slider. In that case, it's a 0.05. Yeah, that looks like a 0.05. Okay, let's cut it out of there. Cut it out, and we'll see what's up. See what is up. There we go. To be in terrible shape. 0.05 written right on it. Very good. 0.05. Okay, so let's give this new capacitor a chance to show its stuff here. Let's see, I'll flip this over. Things are hanging rather precariously from it, but I think we're okay. There we go. So hopefully I can figure out if this is doing its job without necessarily tuning something in. Just the noise should be enough to help us here. Ooh, lots of noise. Lots of bass response in there. There's a bit of a hum. I think there's a bit of a hum in there. I've been fooled so many times when I have the speakers out on my bench here. I cannot hear a hum. I sort of forget about it. Put the whole radio back together, especially these big speakers into the big cabinets, and there's the hum. So there's the rub. Okay, tone. Oh yeah, it's a very nice range. Now, what about that tone? Now go up on a shortwave band. There it is. So I'm hearing a tone, I would guess that's 800 hertz. Maybe very close to 1,000. It's just possible what I'm hearing is the fan motor on my furnace. Yeah, much easier to hear here. Yeah. Oh yeah. It's quite distinct now. Now, there's a bunch of noises in there, but one of them is kind of a tone, so I'm going to try to bridge that capacitor. Now there's high voltage on this, so there might be a little bit of a pop. Hand on the volume, hand off the volume, hand away. Here we go. There was a little spark there. Well, it's having zero bearing on the tone I'm hearing. What could that be? Oh boy, I don't know if I want to go on a goose chase here. What could that be? And while we're thinking about that, why don't we take a look at this thing with an infrared viewer? What? Yes, I have an infrared viewer. This will be my first attempt at looking at the bottom of a radio for heat through an infrared viewer. I don't know how this is going to go. Let's try it out. Okay, so I may have a lot of trouble getting the camera to focus on this guy. So what do I see? Okay, so I see a tremendous hot spot. Can you see it? I can't even see it on the camera, eh? Hang on, I gotta get this to work for you. Let's try it like that. Okay, so I'm going to experiment a little bit, just getting a camera shot to work with this. Literally, this is the first time I've tried this out. So let me see if I can figure out a camera angle on this. Okay, let's try this out. Now, I've already got a camera kind of attached to the viewer. I'm just going to look down at my own legs. There's my legs down there. Can you kind of see them there? My bare legs, which are showing up with a little bit of heat. Okay, enough on the legs. Let's look back at the radio here. So clearly the problem, you see all these hot spots in the back of the radio. The problem for us is figuring out what exactly those are. When you're staring right at the screen, you can't really sort anything out. So I've got another camera angle shot here. Now, there's some funny business on my monitor, some herringbone patterns, but I'm just going to ignore that, and I hope that in the final video you don't see any of that, and you'll be able to see what I'm doing with this. You can see how the camera's held with my thumb. Yeah, you got to try these different things. So there's definitely some hot spots in here, but I mean they could just be ordinary stuff. So let's see what we can kind of go after. So I put this. Oh, by the way, in the camera at the bottom here, if I can get it on there, this thing's always telling you the maximum temperature and the minimum temperature on the screen. It's floating two little plus signs around. Can we even spot them? I think one of them is lost in this big red spot here. The other one's floating up in the top corner, the green. So anyway, it identifies the hottest and coldest spot and marks them on the screen so you can see them. It's kind of neat, eh? Okay, this is going pretty good so far. Let's take a look at something for real now. Come on. Of course, tangled up. I'll tell you where I got this viewer in a minute here. Let's just see if it works first. So clearly down in the corner here, what's down there's a great big resistor. No surprise. And two other items. What would they be? Tricky to see this stuff, eh? Another resistor, one of the ones I put in. Yeah, it's tricky to look at this and know what you're actually seeing. Alright, let's try another spot. There's a hot resistor there. You know, how hot is it? Let's see. The hot is... I can't quite see it here. The camera's in the way. 90! Oh, that's hot. That is hot. Well, that's great. Wow, I can actually measure the temperature. So that's that resistor right there. That's hot. Hot, 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 hot. Let's go on for some other stuff here. Let's go up here. We don't expect any heat. Let's go where we don't expect any heat. That sounds like a better idea to me. Take a long shot. Oh. There we are. What's so hot here? So I think, you know, I can't, this is a little tricky here. I think this is a tube socket right here. And up above it, this curly hook thing. As usual, you know, as an idea, it's pretty great. Look at that. Now, this one, let's get its temperature here. If you look down, you see the big number, 35, 27. So that's showing you what's right in the center. If you look at the center of the screen, there's a white plus sign right here. Whatever you put under that plus sign, it tells you the temperature of it. Unfortunately, my camera is just a little 80. And what is it? It's that resistor right there. 80 degrees. So that guy's hot. Look, he's been resoldered here. So somebody's cut him open for some reason and put him back together. So that's interesting. And it might... How hot is it? How hot is it, Jim? Not very good at aiming this. You know, 70. What am I doing here? Make sure I don't put my fingers in there. 80, 80 degrees. So, you know, that's a little high for a little resistor like that. Maybe that's showing us a problem. That's pretty interesting. Let's keep looking. What else we got to look at here? Something down here. A bunch of things down here. Oh, this is really interesting. Okay, I'm going to turn the camera on its side. So there's a long resistor. You can kind of see it right down in here. Well, obviously that's a high wattage resistor, and it's warm. And again, what's its temperature? 40. So you know that's warm to the touch, but that's not hot. So that guy's okay. So this guy over here was roaring out at, didn't we see 90 or 100 over here somewhere? This guy's running around 80. Hold on, camera. So I'll make up some kind of a jig here to make this work better. Make this work a little bit better. It's not that even now. So other hot things I'm seeing are, don't stick your finger in there, tube bases, because the heat is slowly building up, right? And what's that? So camera lens is dead center. This is a like an open circuit board. This is really a hobbyist type thing here I've got a hold of. You can stick a battery in it if you want. What I've done is I've just, it charges from USB. You can put a rechargeable battery in. You gotta go out and buy it, a special battery, a big battery. You can do that, or what I've done is I've taken one of these batteries, just plug the wire in the top to power it. It thinks it's being powered from USB, but it's coming from just from a battery that way. Well, I think this is really cool. I think I'm going to get a lot of use out of this. I really do. So we're looking down there again. I think it's just the tube base. And it's better rather than tipping it to actually slide it. Keep it parallel and slide it along. You see that resistor 45 down there? That's that same one. There is another resistor right under here. And a little tricky to know what you're seeing in here, of course. The longer we let this run, the hotter the tube bases will become, and the harder it will be to distinguish things like hot resistors and that. Okay, so what's really going up here? Where are we going? So I'm looking just over the top of the radio, right at the light bulb. There's my hand. You can't quite see that. Yeah, I'm gonna have to come up with a much better. There's my hand, yeah. And you can see the light through it. Okay, I don't have to worry about the light bulb. Anything else? What else would get hot in here? Nothing else is going to get hot. I would worry about what would get hot? Like a volume control? No. On-off switch. That's that same resistor there again. Oh, wait a minute. Everything under the sun is getting hot here. I'm going to turn the set off. Let's watch. What I would expect is that resistor would cool off fast. I can also put my... I can block it. I can block it to identify it. Yes, that's the way. Get something to block it. Block the... I need a blocker. Give me a blocker. Anything. Give me something that looks good. Give me a high quality thermal blocker. Just, oh, come on. This might do it. This might do it. Capacitor. Okay. Still got heat there? Anybody got heat? Is there heat there? Oh, this is awkward. Oh, you can see it come right in. That's the way to identify things, for sure. So there's the resistor, right here, and then this extra hot thing. Huh. It's the transformer itself. Now, that's kind of interesting. Let me swing this around without doing it. Just swing it around here. Just swing it around. This can be really useful in my house, generally speaking. Whoa! Oh, okay, so there's going to be hot tubes and all kinds of stuff up here. Okay, I'm going to tip the radio down. Just throw that over there for now. We're going to look at the top of it. Junk on top of it too. Well, let's see what we can get. Let's see what we can see, he says in a squeaky voice. Ready? Okay. Turn this way. Okay, so obviously the two tubes. I need a much better blocker. I need a much better blocker here. Infrared blocker device. Surely I've got something like that. Even a big screwdriver would do it. Big. Okay, there we go. It's a cold item for pointing against hot things. So is it this? Yes. So that's that. That's the one behind it there. What is this? Oddly enough, my screwdriver looks hot. Why would my Okay, so there's a big problem with these viewers. The big problem is not the viewers, it's the fact that things at the same temperature don't necessarily radiate the same amount of energy. And this is a big problem with these infrared viewers. So the basic way it works is things that are shiny metal, if it's shiny metal, like here, like this isn't very shiny, but shiny metal is going to show up much hotter. That's what I believe. The emissivity is much higher, so my screwdriver, look, it appears completely cold here. Why did it look warm back here? But it looks warm back here. Maybe you know what? Maybe it's a reflection. Maybe can you reflect infrared off of metal? I don't know. Oh, lots of stuff to learn. So what am I seeing right there? Right there. What am I seeing back there? There's nothing there. There's just nothing in the radio there that could be hot. So again, it could be reflected. Maybe there's a reflections of heat. Okay, coming this way. That's the tube. I use my hand as the blocker. This tube. You can see this one back here. My finger. Oh, sorry about that. You have to look at two cameras at once to kind of see this thing. But what about that transformer now? So you can see this can is green. It's this is another way to use this. Be moving like this. But this transformer has gotten hot. How hot? Okay, so you know, to the touch, it's just warm. It's not hot to the touch. So I don't think there's a problem there. And nothing else really should be, you know, I shouldn't really find heat anywhere but up here, but those tubes. And by now, anything that's like a hot resistor or something, if there was one up here, it would be cool, probably cooled off by now. What about that big capacitor? Does that have any heat showing? No. So I see a big green thing in the middle here, blocking. It's blocked. So there's another way to see things, is to use hot items like tubes, and then to hold the camera in such a way that the other item you're interested in goes in front of it, you can see the other item then, because it's not quite a shadow, but kind of like a shadow, isn't it? I guess it's a shadow onto the lens. Okay, I'm learning as I go here. I think that's it. Now we're going to do the classic experiment with this thing. I'm going over here on the floor. This is my floor. Okay, see it's turned blue? I'm turning blue. It's cold. On the floor, I put my hand on the floor. Now hold still. I'm holding my hand still. I don't have to hold the camera still. I'm going to remove my hand. Here we go. This is the experiment. Wow. Not much left there. My hand got really cold. Actually, you can see that the center of my hand stayed warm. The rest of it got really cold. So I didn't heat the floor. I colded my hand. Let's try it again. Not on an ice cold floor though. This is the classic. This is the classic. It has to pass the classic test. Okay, let's try it on this thing here. You got no idea what I'm talking about. This is just a piece of wood. Room temperature. Hand on it. There it is. You see my hand? Holding my hand still. And I'm going to take it away. Aha! And there, the heat print remains. Very cool. So, you know, there's not a lot of heat in this piece of wood, and yet this detector can spot it. So, fantastic. Well, that's a great first experience with this guy. I'm really looking forward to making good use of him. And again, around my house, there's 1,000 things I can check. Because you can, like for instance, had it out on my deck. My deck is hit by sunshine. The top of the surface of the deck gets really hot. How hot does it get? 65 degrees centigrade. I know because of this thing. I get a whole pile of stuff I've looked at, but not in the shop here. Today was my first shot at this. Fantastic. So where did I get this? I got this from Banggood. Banggood is a Chinese distributor, kind of like Amazon, those kinds of companies. It's just out of China. Banggood. Is there a name for this thing? There may not even be a name for it, so maybe I'll hunt it up on my computer screen so you can see, because my first experience is very, very positive. I'd have to bet a number of you are pretty interested in what is going on here with that thing. Give me a second while I just fix something here. Do it live, do it live, do it live. And what did we find out? Well, there's one resistor that looked to me like it was too hot. Yeah, I got to get back under and look at it. Let's take care of the viewer first. I'll find the web page for this viewer, and then we'll know exactly what the name of it is, because I don't know offhand. Okay, so it's just Google. I just typed in Banggood thermal viewer. There it is. So there's a couple here from Banggood. This is the one I've got here. So there it is. So, oh, I got some money off. What is that? Let's see. $122 Canadian, but this price varies every time you look at these screens. That's how these kind of sellers operate, right? The price is different every time you look at it. 33 sold. So interesting. I've got one of the first 33. This is a bit of an experimenter's device. It's not super rugged, although it looks pretty good so far. Actually, I'm pretty impressed with it. I shouldn't say too much until I've got more experience with it, but just in case you're wondering, there it is, right there. The Danyu HY01 MLX 90640 infrared viewer imager, with or without shell. The one you saw me use is with the shell, so you can buy it, just kind of the inside parts. Anyway, that's enough of that. I don't want to go on at length about it. I just know you're going to be interested in this guy, because wow, the potential is great. So I should flip this back up and take a look at that resistor, and I think we should really replace it with a higher wattage resistor, because at that temperature, okay, so here's the rules on temperature. Normal, everyday, organic materials that are commonly used in electrical apparatus, which are selected for their heat resistance, like paper, things like that, can sustain about 90 degrees C for years and years and years and degrade at a very slow rate. You go above 90, the rate of degradation begins to increase. By the time you get to about 120, the rate of degradation, different materials are going to behave differently, is significant. So if you're measuring something in your radio at 120 degrees C, you take a look at what the heck it is. Obviously, if it's a piece of glass or a piece of metal, it doesn't matter. But if it's a piece of organic material, and I'm really putting big quotes around there, maybe you should pay some more attention to it. Okay, let me just... So I'll have to do a video just on this thing once I get more used to it. But I think you're going to see this a lot here in the shop. Which is the on-off button is up here. Wink, off. Great. Wow. Okay, so that's a bit of a dream come true. You know, I kind of dreamed about doing that. Probably for 30 years, believe it or not. Yes. Okay, I won't go into my thermal viewer experiences, but I have some from the past. So let's get at that resistor. I think I'm going to flip it this way. Let us get at that resistor. Now, the resistor. I flip the radio over. Here's the resistor in question. So it's yellow something. Because it's heated, I think the something has lost its color. But my guess, 47 with 2 zeros. 4700. Okay, can you find something like that? Is it? Oh, look what's just showing up after all this time. I knew you'd show up sooner or later. I don't know, it just seemed to show up like magic when I moved this piece of paper. Okay, lucky break. Yeah, this resistor. It's going from... Well, you know what? This one, how come I didn't see this one is hot? It looks almost burned. And those two are in series, or at least they're tied together in one end here. Let's figure this out. Oh, the easy way, the easy way. Let's figure it out. Let's do it the easy way. Like cheat sheet here. Make sure we've got this angled the right way. Here we are. So for a resistor R3. So this shows, yeah, R3 coming over to this terminal strip, and then there's R2. R2 and R3. What can we find out about R2 and R3? Well, first of all, pretty low numbers. There's R3, I found it. There's R2. Thousand ohm, so and the 3900. Wait, I didn't see 3900 there. That's 47. So somebody replaced this resistor. They replaced the 3900 with a 47. The 47 tiny one. And R3 1000. We'll see this one's cooked. Commonly when you find a 1000 ohm resistor in a circuit radio like this, sometimes they are put in there as essentially fuses or test points for reading current. Test points for reading current is probably what they're really in there for. 1000 is easy to read the current across. That's not what I want. I want to see parts list now. Let's see what the parts list says about these two guys. Somewhere in here. The parts list. Here it is. I want to find R. There's R4, quarter watt, 2.2. No, R2 and 3. What am I saying? 4. R2, half watt. 39. Yeah, 39. That's right. 39. Same thing it shows on the schematic. Half watt. And what's in there? Quarter watt. I'm pretty sure that's a quarter watt. And that's why it's hot. It's the wrong size too. So we'll put a 3900 1 or 2 watt resistor in there. Wow, the viewer paid off. That's fantastic. Really, that's really exciting stuff. Can't believe it. First shot at using it. 39. Looking for a 39. Yeah, 39. Okay, so 39. Is that 39? Oh, white. Is white 9? White? Oh, it's such a big number. Regardless of what it says, we need to test it to verify what it actually really is. As soon as I find my meter. Where's the meter? Too much stuff on my bench. Oh, here it is. More or less in front of me. $39 or very close, please. 42. 39, 42. How do you get 42 out of a capacitor that has an orange one there? Let's try another. I got a bunch of these. 43. That makes you wonder about this meter. Let's try another one. You gotta wonder about the meter at that point. Let's try it with this one here. As I've said before, the problem with these meters is they give you numbers. It's up to you to figure out if the numbers mean anything. $42. Well, isn't it interesting? Every one of these has gone to the same place. 42 from, I'm sure this is 39. Well, I'm not sure. I think it's 39. Well, it's a nice capacitor, nice resistor rather. Nice big high wattage resistor. Let's try one more. How interesting that they've all gone to the same place. So this one's just a little less than the others. 41. Okay, so I was part way through putting this one in and I realized I gotta change this guy. He's definitely cooked. Let's check him out. $4,100 ohms. That's supposed to be 1,000 ohms, isn't it? Isn't that supposed to be 1,000? Ah, well, I really hit on something here, didn't we? So, where was I? Where was I? I was looking at a different piece of paper. That's where I was. Looking at this. And looking at, let's get this held the right way. R3 and R2. There's R1. Right into a plate. Ooh, this is a wire wound resistor there. We won't touch that guy at all. Oh, L8 it says. L8 and R1. Whew. So that's a wire wire wound around a resistor. Ay, ay, ay. It's going to a plate and nothing else, so we can test the resistor. Not with the coil there. Not with the coil there. And what is the resistance anyway for R1? R1 plate of something. R1. 5. R1. There it is right there with a coil across it. 10,000 ohms on the resistor, 6 ohms on the coil. 10,000. And look, that's right in line with this guy and this guy. So, let's see, 10,000, and this is 4 and 5. So half the power, 4 times as much power is being developed in here. Is that right? I squared R? Not quite. Same I squared. So double the power being developed here over these two combined. But with this thing rising up to 4,000 ohms, and this guy going up also to 4,700, these two have kind of robbed power. We don't want power here anyway. They've robbed some power from here. So I'm trying to deduce whether this resistor is shot. What if it is? I'm not gonna wind another coil. If I take a reading on it, well, you know what? This is a pretty smart meter. Let's give him a shot. Let's give you a go. Can you do it? So as this one, I'll replace with a higher wattage, 1,000 ohm resistor, or is that'll kind of undo the fusing. I don't think it's meant to be a fuse in this radio. I think if anything, you read the voltage drop, it gives you the current, and then you know the current through the tube. Something like that is happening here. Where am I going? What am I doing? I'm going here. I'm going here. What does it say? It says it's a resistor, 2.4 ohms, and a little bit of inductance there. Interesting. So it thinks it's a coil. That's all it knows. 2.4 ohms. Isn't that roughly what it was supposed to be? Isn't that what it was supposed to be? It's supposed to be 6 ohms. Right. No, that sound didn't come out of my head. No. Okay, so we got to get a 1,000 ohm, fairly decent wattage resistor here. Show me 1,000. I have many to choose from. Here's one. That's pretty high wattage. Question is it 1,000? So some of these are pretty old resistors I've got here. Just been sitting around for decades. 1,000. Excellent. It's in good shape. Okay, so I'm going to fit that guy in there and finish off this guy, and we'll have gotten rid of some bad resistors right at the last minute. Thank you, thermal viewer. So unfortunately, where I want to connect this resistor right to the chassis here, I left a lead tail sticking out of that. That lead tail was damaged. I just wiggled it and it broke right off. So now I have to try to solder right to the chassis. I can't do it. My soldering iron just doesn't have the oomph. So I need to find another grounded spot here within range of this resistor, somewhere in here, where I can solder it. Quietly looking. So it looks like there's a string of terminals here. See how these are all wired together? Those are probably grounded. So the ground terminal, I just can't quite see the quite see all the way, but I bet you this is just a ground terminal here. Zero. Yeah. So that's a ground terminal, so I can use that terminal. Now, is there a problem with that? You go to the chassis probably for a good reason. And maybe I'm giving up too soon on that chassis connection. They're either going there because it's simply really convenient. Why wouldn't they come down here? This goes right to the chassis over here. I don't think I'll ever get this soldered onto the chassis properly. Not without bringing in a blowtorch. I think I'll swing this down to this terminal here. I have a blowtorch. I have a blowtorch and a thermal viewer so I can examine all the damage I did with it after I've used it. Okay. Are we not set? We should start this guy up. Put the thermal viewer on it again. Yeah. Let's do that. Okay, so this time he's hanging the other way here. But it looks good. All looks good. Okay. Switch is off. On. Boom. No boom. Just kidding. Didn't the light come on? I didn't see any lights. Tubes are heating, so we're okay. Hand on the volume. Okay, there it is. Tone. It did actually. What's that? That's a huh. What is that? That's some weird thing. I don't think that was tuned in. Maybe it is. I don't think so. I don't know. I got it turned up pretty high. Maybe that's what's really going on here. Still hear that funny tone. What's the chuck 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 chuck? What's that stuff? Say about this thing. Stand back. It's gonna blow. Yeah. What band are we on here? Volume down, volume down. Weird sounds. Oh, it's got a lot more volume. That's what's happened here. Okay, so we're on the push buttons. A band. How come it went so quiet there? A band, very weak. Extremely weak. What? What? Am I throwing the alignment all off crazy doing that? Okay. I gotta look in the hole here. Maybe I've got it way off on the wrong band. Let's go this way. We'll go this way with it. No, we won't go this way. Oh, for crying out loud, man alive. Hey. Why are you like that? So B, so push button and A is kind of the same thing. It's not the same kind of radio, just an AM broadcast receiver. Why so loud? Working good. Not working so good. What happened? Is it not working good? Maybe it's working great, and I just haven't. A lot of weird stuff going on here. Maybe I got a wire loose. Me personally. I personally have a wire loose. Hooking that resist. Surely that can't be good. Maybe hooking that resistor other than the chassis is a mistake. Maybe. What else could I have done that's wrong? Okay, so we're using this just like this because we're just going to look at the. There we are. The resistors I put in. Not even showing up. Something didn't work out here. Something did not work out here.